Okay, so we've now got the absolute value or the modulus with an inequality. So remember how this modulus sign here, that meant the absolute value. Absolute value. And we might call this a modulus sign as well. Okay, so what we're going to do is we're going to do this exactly the same way as we did our equations. We're going to do the first way with x is greater than 10. And that's solved. But the second way would be to take a negative x is greater than 10. Now we're going to divide both sides by the negative value, and what we've got to remember is that that will switch the sign around like that, negative 10. So if we read this, I've got x is greater than 10, x is less than negative 10. And if I wanted to, I could draw a number line. And on the number line I could put the 10 there, and I could put the negative 10 here. I want them solid because they've got the equal sign in there, and I could write that. Now obviously these are going to be slightly more challenging, so we'll do this one. So the first one is with the positive value. Do some algebra with this. That's less than 14 when we take away 3 from both sides, and now it's less than 7. And on the other side we have a negative of the whole bracket. And I'm going to divide both sides by that negative 1 to begin with. That switches that sign around and it becomes negative 17 when I divide by negative 1. So now it's just the algebra again. Whoops. Greater than, and I take away 3 from both sides and I get negative 20, so x has got to be greater than negative 10. So if we look at this, we've got a closed one here. If I do my number line, and on my number line I put the negative 10 and I put the 7 here, and this time I'm going to have an open and an open, but I'm going to have a straight line between them like that. Let's keep going. Let's do another example. This one here. Okay, so the first thing we need to do is add that 4 to both sides. So it's 3x divided by 2 plus 5 is greater than 12. So 3x plus 2. Now we're going to take that 5 from both sides to give me 7. I'm going to times both sides by 2 and then divide by 3. So that gives me 14 over 3. Now that's fine. I can just leave it like that. Not a problem. Now on the other side, it would have been negative 3x divided by 2 plus 5 is greater than 12. And then we get the 3x over 2 plus 5. Switch that sign when we divide by the negative 1. So here we have 3x, whoops, okay, we have 3x divided by 2 less than negative 17. We're going to divide, times both sides by 2, which gives me negative 34. And then we're going to divide by 3. Now I think I've just about got enough room here for a number line. Here. And want it less than negative 34 over 3 and greater than 14 over 3. And I want to use this open circle here and an open circle here. Okay, so the last one is where I've got double identities on both sides. So what I'm going to do with this is just first of all let's make this a greater than or equal to sign in here. Okay, so the first thing I can do is do the 3x minus 7 greater than x minus 5. So absolutely no problem there. This is just like a normal inequality. So I'm going to take the x from both sides rather, and add 7 to both sides, giving me 2, and x is greater than or equal to 1. That's a nice easy one to do. On the other side, we're going to have negative of the bracket 3x minus 7 is greater than x minus 5. Now I'm going to times both sides. Let's just put a line down here. By negative 1, or divide both sides. Now when I do that, I get this, and I get 5 take away x. So I've multiplied both sides by negative 1, and because of that, it's an inequality, I flip that sign over. Now when I add this negative x to both sides, I get 4x less than 12. So x is less than or equal to 3. So now we're ready to draw a number line. On one side, I want x to be bigger than 1. Now if we look at this, we've actually got x less than 3 and x greater than 1. So we've actually got a closed part here. So here we've got the 3, and here we've got 1. And we want to do some closed circles and join those together. And there are my nice inequalities.